So now that we've had a chance to look at different ways of programming Java threads, different types of threads, user threads, daemon threads, and so on, let's take a step back and evaluate what we've learned up to this point. Basically, we want to look at the pros and cons of these different Java thread programming models. And we're going to use our GCD app just as an example to be concrete in our analysis, but be aware that the topics we're discussing, of course, are more general than just GCD. So let's start off with the pros of extending thread. So it's very straightforward to extend the thread superclass. You can see that's what we did here with GCD thread from our example from earlier. All you have to do is just override the run hook method, piece of cake. All the state, all the extra methods, constructors, and any accessor or mutator methods you might need are all conveniently consolidated in a single place in the program. And this allows nice central allocation and management of the thread. So you can see down here, we can make ourselves a new thread. We can set the activity. We can start it. It's all nice and integrated in one object. And this particular design is very helpful if the thread has to be updated somehow during runtime configuration changes. Now that's kind of an Androidism. Not all uses of threads need to be concerned with runtime configuration changes, but runtime configuration changes are basically what happen when you take an Android phone and you rotate it from portrait mode to landscape mode and vice versa. And there's various clever things you can do if you have everything in one place to update the thread state and other information it might need. And this allows you to interrupt a thread, restart a running thread, read and write its state in a very convenient way without having to keep track of multiple pieces of information. You just have to keep track of the thread object itself. But of course, there's some downsides with extending thread. And one of the most obvious ones is that the subclass has to extend the thread superclass. And if you recall the semantics of Java, which hopefully you learned about when you were taking earlier classes on Java, that can be overly restrictive since Java only allows one superclass per subclass. So once you've extended thread, you're locked in, you're stuck. You can't extend anything else. So that's where Runnable comes in, because Runnable has this nice property that you can have multiple implementations of interfaces without running into this problem of only having one thing that you're going to be customizing. So remember, a subclass can only extend one superclass, but it can implement as many interfaces as it may want. So here's a very simple example just for fun. You can see that we have GCD Runnable, which could implement Runnable, could implement serializable, could extend random, blah, blah, blah. But the point is we could have multiple interfaces that it's going to be implementing. So that gives you some extra flexibility. And therefore, you can use some other superclass besides thread in order to provide other things you might need. So that's, again, a bit more flexible. One of the nice things about using runnables is they can be reused in other contexts. Now, we won't actually get to this for another couple of weeks, I guess, at this point, but we're going to be talking about the Java Executor Framework soon. And your second programming assignment, especially assignment 2A, will focus on the Java Executor Framework. And one of the cool things about the Java Executor Framework is you can take a runnable, like the GCD Runnable we just implemented, and you can go ahead and put it into a thread pool. So those runnables can then run in a pool of threads as opposed to being limited to a single thread. In contrast, if you have extended thread, then that computation is going to run in that thread and that thread alone. Of course, there's cons with implementing Runnable. Just like everything, there's always trade-offs, as you might imagine. And one of the consequences of having the Runnable be implemented separately from extending the thread is there will be more moving parts. So you have both a runnable object and you've got a thread object. And those two entities have to be created and managed and accessed separately because they're two things, not one thing integrated together. And normally this isn't really a big deal, but in some cases, this decoupling between runnable and thread can be complicated if the program needs to access the state of a runnable but only holds a reference to the thread object, or vice versa. If you only hold a reference to the runnable and you need the thread, or you only hold a runnable to the thread and you need the runnable and so on, whichever way you go, you have to keep track of multiple things, and that can get a bit more complicated. In practice, most Java and Android software that uses threads implements Runnable rather than extending thread, because it just gives you a bit more flexibility. And in fact, nowadays that Lambda expressions have become popular, they're often used to provide a anonymous implementation of a Runnable that can be passed to the thread constructor in order to be able to perform computations in a very concise way. So as we see here, you can see that we're just passing in a computation as a Lambda expression, which will print hello world in a background thread. And there's no need to make an extension of thread. We don't have to implement Runnable per se. This really is an implementation of Runnable, but it's an anonymous implementation of Runnable, and therefore can be more concise and in some cases easier to understand based relative to other ways of doing things. So at this point, we're really done with our overview of Java threading. You should now have all the information you possibly need in order to be able to do assignment 1A, which is very simple. When you do assignment 1A, please make sure that you go and watch the video I put out last week on the frequently made mistakes that I'd seen up to that point, and try to make sure you don't fall into those frequently made mistakes in your solution. If you have any questions, of course, please feel free to come to office hours or post them on